Okay, we're recording. So, welcome to Contributors Community Hours. And Benjamin is going to help us understand Istio CNI better. Thanks, Benjamin. Please go ahead.
All right, thank you guys. I'll try. So I'm going to get started kind of explaining what CNI is. If you're not familiar, you've probably seen this logo to KubeCon, various places. It's the container networking interface, right? And the way this works is basically whenever you create a pod in Kubernetes, right, that has to set up each container, right? It has to talk to the container runtime to set up each container, right? It has to create has to create the C group. It has to create the network namespace for those containers. It has to, basically tell the container runtime to, spin up these containers in the cluster. CNI is a way for the networking to happen there. And CNI largely exists because Kubernetes does not want to really deal with networking, and the container runtime does not really deal with networking. So we are left with CNI, which is sort of an interface for that to happen through the container runtime, but the container runtime does not actually know or care about networking. It just sort of triggers it. So the way that works is the kubelet tells the container runtime to start containers, and the container runtime uses this libcni. Usually, there's this thing called libcni over here in CNI. It is basically at the point the container runtime spins up a container, it goes and checks a config file in the node, which is usually like it's like an etcni net.d or it's a path on the node, which I'll show you later. But it basically reads a JSON config file and says, okay, I got to start a container. What network plugin should I run? And once it reads that JSON file is basically a few arguments and a list of like binary blobs sitting on the node. And the container runtime will then go, okay, well, I'm going to run these binary blobs in the order to define the config file, and that's going to configure the networking for the pod, right? And it does this every time you start a container. Basically, it's going to do this, and that sets up like network interfaces. That sets up routing, whatever else you want. It's basically just a way to run random binaries on the node from a config file. It is not more magical than that. That's how everything in Kubernetes works in terms of networking. It's a little janky, but that's all it is. It's not anything particularly fancy. So that means that every cluster you've got has got a CNI in it. And every time you create a pod and containers, those plugins on the node are being invoked, and they're setting up networking. Let me actually see if I can just actually jump into, let's see if we can find this. I think it's CNI net.d. Yeah, so any Kubernetes node, usually it's going to be at this well-known path. And if you look at, this is just a kind cluster I've got sitting here. And if you look, let's take a look at kindnet, right? And this is that JSON file, right? It's basically saying, hey, here's an array of plugins. And each JSON object is a plugin. So this is a plugin, and then this is a plugin. And you'll see I've already installed Istio because we've got another blob here, which is ours, Istio CNI. So there's two plugins in this config. So basically every time, like I said, a pod/container is started up, the container runtime, whether it's CRIO or whatever, they all support CNI interface. They'll know to go look for this config file and exec these binary blobs. And if we go up here, oh, where's the binary location? I forget where it is. OptCNI bin, there it is. So if we go look for where those binaries are, we usually install those, or again, by convention, not always. These are in OptCNI bin. All right, and if we look here, we'll actually see there's a bunch of just binaries sitting here, right? They're just executables. That's all they are. And they are executed based on this config. So again, just to kind of reinforce, it's not magic, right? It's just a JSON blob that the container runtime sucks in, and then it just literally raw execs binaries, which means it's privileged on the node to run whatever on your node, and it's just running these binaries in order. That's all it does, really. That's what CNI is. And it supports this concept of chaining, right? So you could have more than one plugin and more than one binary in the same config. So for instance, for this network named kindnet, it'll run these two plugins in sequence. And the CNI will do things like the output of the first plugin gets passed as contextual input to the second plugin, and the output of the first and second plugins would get passed as contextual input to the third plugin, so on and so on. That's the chaining model, right? Everybody has the context of the previous plugins in the chain. It's a little janky, I have to say, but it does work for the most part. There are a lot of corner cases where it doesn't work, as you can probably imagine, and there's some work to improve that, but that's kind of how it works in general. That's CNI, right? That's how it works. It actually runs binaries on the node to set up things. And it's just driven by a JSON blob sitting on the node. Every node has that. All right, now, the next thing we might want to talk about is, so how does Istio interact with this, right? Istio has, you may be aware, hopefully, let me zoom this a little bit. Istio has this thing called Istio CNI, right? Which you may have seen in the documentation. And you might say, wait a minute, well, CNI is designed to basically get packets from one pod to another, from one container to another, right? It's designed to set up the basic layer 4 networking, right? So does Istio use the CNI to do any of its networking stuff? Not really. Can Istio work on its own as a pure CNI without another CNI? No, it's chained. The way Istio works is it expects you to have a CNI already there. For instance, KindNet, right? We've already got one plugin there. We always caboose onto the end of the plugin chain in Istio, right? We inject a plugin that does not do all the networking setup, but it runs in sequence with what you've already got there at the end to do any extra configuration that Istio needs, right? So we need you to already have a CNI, you know, Cilium, Calico, whatever. We need you to already have a plugin defined, because our plugin will not actually configure node networking from nothing, but it will take something that is already configured to have packets being routable between pods and, you know, set up the Istio specific bits, which is, you know, redirection to proxies for encryption inside the pod, whatever else you want to do, right? So we sort of piggyback onto whatever CNI you've already got by adding an extra plugin on the end. And if you're familiar with the Istio CNI daemon set, right, which is an option that you can install, and previously it existed for sidecars, like the Istio CNI daemon set, which is a Istio component, or the node agent as it's probably better called. It existed before Ambient, and it was used if in case you did not want to have a privileged Istio init container for your sidecars setting up the IP tables rules within the pod, right? Because in sidecar mode, we're sticking an Envoy proxy in there, and your app is also in there. But we need to like actually configure networking rules inside the pod so that the stuff from your app gets sent through the Envoy proxy that's sitting next to it, right? Because otherwise it wouldn't. It doesn't know it's there. That's where you got to write those IP tables rules. You got to configure the networking. The old way to do that, the old way, was we stick a privileged init container into your pod, you know, when we inject the sidecar as well. We stick an init container in there, which has to have privileges to mutate the networking rules in your pod. It has to be relatively highly privileged, like netadmin, right, inside the pod. And it would like actually, before your pods, or while your pod's starting up, it would rewrite those rules and make sure that the redirection is in place so that your app would go through the local Envoy and then out, right? Because something has to do that. The CNI node agent was introduced after that point for sidecars as a way to do that from a single privileged node agent that would jump into the pods and do that on startup, rather than having to ship a privileged init container that goes into every pod. So currently today with sidecars, you can choose either or. You can have a privileged Istio init container, which will do this, or you can not do that and have the Istio CNI node agent deployed. It will install a binary blob on your nodes. It will chain with whatever CNI plugin you've got. And whenever a pod is created, after all the regular CNI stuff runs, ours will run, jump into that pod for sidecars, and configure the redirection through the local Envoy. So it's either or. There are different security constraints where you might want to have a privileged node agent, but not have a privileged init container in every single pod. And that's what the Istio CNI was originally created to service, that need, okay? And yeah, if you go look at the actual tree here, there's a README that hopefully explains most of this, right? What it does, the privileges required, that sort of thing. But if you go, basically what, but all it really is, again, is a daemon set. So go ahead and back out. I've already installed Istio 121 here with ambient mode enabled, but you can see we've got 3 nodes, right? Standard kind thing. And each one has got a CNI agent. And I've got debug logging enabled, but this is just a daemon set, right? That runs on every single node. And it is responsible for mostly when it starts up, remember that CNI config on the node that etc net CNID, that we actually have to write, we actually have to append that JSON blob with our plugin to the end of whatever JSON blob you've already got sitting on the node. And we've actually got to drop that binary in that well-known location when the node starts up. That's what the CNI node agent does, and does with sidecars as well. As it when it first starts on the node, it looks at that config file, it makes sure the Istio config is at the end of it, and it drops that binary blob in the system configure location for CNI plugins. And then we'll continually watch both the plugin and the config file to make sure that our entry stays there and is not removed. There are a lot of bugs where if you have multiple node agents mutating that config, it can get a little hairy. That is a systemic problem with the current CNI spec, which there's some PRs out to fix that hopefully we can improve by using a more system D init system style thing. But that's what it does, right? The CNI agent, node agent, Istio CNI node, it's just sitting there, it's watching that config file, it's watching those binaries, and it's making sure they're always up to date. And whenever, and then, so that's for sidecars, that's pretty much all the agent does, is it just sits there and makes sure those binaries are what they should be, right? Now, for that whole sidecar thing where you don't want to use an init container, and we need to use the CNI to actually set up those sidecar networking rules, how does that work, right? Does the CNI agent daemon set itself do that? No. And sidecar, it doesn't. What it does, this binary that we add as our plugin, again, remember, these binaries are all invoked every time a container is initiated, right, on the node. So our Istio CNI binary, not the node agent, but the thing it drops into that well-known directory that's automatically executed, that thing is what actually will, when a pod starts or a container starts, that will configure the sidecar networking, right? So again, the container runtime, every time it starts a container, it'll run through that whole chain of binaries and run them in sequence. Ours is in there. Ours will go, okay, the new container is starting up with sidecar mode. I can, interrogate Kubernetes API about it to some degree because it is early in the process. And I can know that the networking is already set up, but I can jump into the pod network namespace because the network namespace is one of the arguments that the CNI plugins get, right? You would need that to set up networking. We can jump into that and set up those run IP tables basically inside the pod from this plugin sitting on the node. So in sidecar mode, it is actually this Istio CNI binary that is run for every pod. That is actually what would do the job of what the init container used to do. This binary is run as root. It jumps into the pod when the pod starts. It configures the networking. It jumps back out. Your pod is up now, right? And again, in sidecar, all the CNI agent it does is make sure this config is up to date and this binary is up to date, and that's it. It just sits there watching files basically and writing them out as it needs. Okay. That's sidecars. That's what CNI node agent used to do. Okay, and that's mostly covered through this. Now, in ambient, it's a little different. In ambient, we are not deploying sidecars into the pod, but we still need to jump into the pod to redirect traffic, right? As you know, with the in-pod stuff we have, zTunnel is actually opening listening ports inside each of the workloads. Right? So it's as if you had an envoy in there with listening ports locally, but there's not actually an envoy in there, just the ports are there. But in terms of like actually routing traffic, it looks the same, right? Stuff needs to leave your application. It would normally leave the pod, but we need to have rules that say, no, actually go down through these ports first, and then, basically redirect inside the pod. So we still need to do the same task. So in ambient, we use the CNI node agent to do that, okay? And again, it's sitting there as a daemon set. And we have in here, if I can find it. Okay. Source. Yeah, so in the actual node agent, we have a config flag, right, that's ambient enabled for that CNI node agent. So if you just deploy the CNI node agent without the ambient flag, it will do the sidecar stuff that I talked about. But if you deploy it with the ambient flag enabled, it will do all the same stuff. It still puts the plugin out there. It still adds the config to that node config file. But additionally, it starts a watcher, which, where does that guy live? I think it's in here. So it actually starts a listening server. Yeah, so you can see if ambient is enabled, then in addition to the normal stuff we do, we copy the plugin out and we update the config and we start a file watcher to make sure those guys stay in sync. We also start another server process here called the ambient node agent service. And what that does is listen for new pod events. Now you might be saying, well, wait a minute, we're deploying a plugin, right, that starts whenever a container starts. And we know it's going to execute every time a container is spun up. So why do we need to watch the Kubernetes API too for new pods when we already know we're like directly in the chain? Yes, sorry.
Oh, is it the same plugin for ambient?
Yes.
Okay.
It is the same plugin.
Okay.
And again, the plugin has a config file that we basically, it has a config that is passed down to it, or we pass an argument to it that says, do ambient stuff. I'm about to get into that.
Okay, cool.
Yeah, but the server, you might say, why do we need to have it, why do we need to watch the KDAS API server if we already have a plugin we know is in the chain that will always, unequivocally get executed when the container starts? Well, the answer is because with ambient, right, we have this concept of labeling and unlabeling. So we need to catch pods that are newly spawned, and that is what the CNI plugin will do, right? We know it will run when a new pod starts. But if you've already got pods running and you add an annotation or a label to say include these in ambient, well, they're not going to restart, and that plugin would not rerun for those. So we still need to know, we still need a way to get those pods and jump in, right? So that's why we've got with ambient two different things. We've got the plugin, which will catch pods when they're newly spawned, and we've got the node agent watching the Kubernetes API so that we can know when the namespace is labeled and there are pods that are already started, we can get those too, right? So we have to get it from both sides, basically. Do we have another question? Yes. The nice thing about the CNI plugin, and to Daniel's point, the nice thing about the CNI plugin is it is always first, right? Actually, the CNI plugin will often be executed before, usually not before Kubernetes knows about it, but like if you've ever seen a scenario where Kubernetes doesn't have an IP yet for a pod, right? If the Kubernetes API might report that a pod is scheduled, but there's no IP. That's because the CNI plugins haven't finished executing. The CNI plugins are responsible for making sure that pod gets the IP. So the CNI plugin actually would see that IP, for instance, before the Kubernetes API server would, because that chain is responsible for actually establishing that stuff. Okay, so we got this server process, which is watching the Kubernetes server, and if it sees existing pods that need to be added to ambient, then it will get the net namespace and jump into them and do the networking rules. But then we've also got that startup thing, right? So the plugin, if I can find, I forget where it lives. Plugin, yeah, okay. So the plugin, so again, in Sidecar, the plugin actually did the IP table stuff, right? In Sidecar, the plugin had all the intelligence. It would always run on startup. It would inject the IP tables rules. And ambient is a little bit different. We don't always come into an ambient pod from the plugin, right? Sometimes we come in from we know that it's already there and the namespace is labeled, and we need to jump into it. It's not starting up. We still need to get into it, right? So we're not always coming into a pod in ambient from the plugin. So in ambient, the plugin actually does something a little different. Again, if it has a configuration that says ambient is enabled, what the plugin will do is instead of actually jumping into the pod to configure the rules like it would in Sidecar, the plugin does nothing except push a gRPC message to that Istio CNI node agent saying, new pod came through. Why don't you set it up, right? So this is a little bit of a change from the Sidecar approach. Rather than the plugin actually being responsible for the IP tables rules, in ambient, the plugin does nothing but send an event synchronously to the CNI server, say, here's a new pod, you set it up, and then when it gets a response, it allows that CNI chain to continue, right, with whatever else you've got. So it is much dumber in ambient, right? The plugin, it does nothing but push something through that gRPC channel, basically. So that means that that agent, it's getting stuff pushed from the CNI plugin for new pods. And anytime you have an annotated namespace, it's also getting basically stuff pushed in from the Kubernetes API server, right? So we're getting two data streams coming into that agent. And it basically can say, okay, CNI plugin tells me there's a new container. Let me get its namespace, jump into it, configure it, say return okay. Kubernetes tells me that there's a new pod I need to configure. Okay, well then I'll jump into it, return okay, right? It's the same thing. So basically we've sort of changed the order so that those are two data streams that go into that node agent. And it's listening for both of those events. That can be a little tricky sometimes because you may actually get events twice, right, for the same pod. If a pod starts up, remember I said CNI will always fire first. So the plugin will give that agent an event. And then after that, Kubernetes might also tell you, oh, there's a new pod. So we have to have some intelligence in that node agent to say, I've already got it from the plugin. I can ignore the one from Kubernetes. It's already been annotated or whatever. We actually annotate pods when we redirect them in that node agent. So we know if it's already come through, basically. We know if the plugin has already caught it for us, and we don't have to do anything if we see it on the Kubernetes side, and vice versa. Okay. And yeah, all this plugin really does is, again, it starts this gRPC client, it pushes to that node agent, and communicates to it that that we've got a new pod, and then it just stops. So for ambient, the plugin is much simpler and is just a shim basically.
Hey Benjamin,
Yes.
I just added a couple of quick questions on the sheet.
Okay, let me take a look.
Bring that up again. They're kind of, and then I did have one more follow up, which I haven't added to the sheet yet.
Yeah, multiple app containers per pod. Yeah, that doesn't make any difference for us because we are only interested in the pod. You see, right? Like we aren't the primary CNI, so all we have to do basically is be informed when a pod is created. The primary CNI would take care of networking for each container within there, and we are only monitoring pod creation events basically. So we don't care about containers. That's taken care of already, basically. The reason that works is because in Kubernetes, pods are the security boundary, right? So a pod has a network namespace, right? And there may be subdivided within that multiple containers that I don't actually know, they may or may not have their own, inner network namespaces, but we don't care about those.
No, they don't. They have just the one network namespace.
Right, just that, okay, yeah. So the only one we need to care about is the pod network namespace because that's the only one there is. That's the one we watch, and that's where we set up the redirection. Primary CNI, any known issues for Istio CNI when the primary CNI itself is a chain of more than one plugin? No, not really, because we aren't depending on any inputs from previous plugins, right? We are literally just using it as you need to guarantee that I get invoked at the end. I don't care what happened before. As long as when you get to me, I'm the last one, the pods are routable normally, and I can get the network namespace of the pod in question, that's all we need. So we don't take in any inputs from the previous plugins in the chain and do anything with that. We only take in the stuff that all plugins in the chain get, right? Stuff like the network namespace or whatever else. We expect that the IP would be assigned by the time we're invoked. But again, if we're at the end of the chain, that would necessarily be true.
If for any reason, any of the primary CNI drivers happen to reorder the plugins, and then we watch it and we put ours back at the end. So there is a short time frame when the Istio CNI may not be the last plugin in the chain.
It wouldn't so much be that, right? Because it's a JSON file that everybody has to read in, update, and write out. So we can have situations, and we have seen them, where you have maybe this can happen actually with Cilium and Istio, because Cilium also has a node agent that is also watching that config file. that is also trying to stick its plugin config in there and is constantly watching it to check for updates. And if something changes, it tries to re-inject itself. So you end up having two daemon sets fighting over the same shared config file in the node, which is gross. And you could have issues there where if Cilium is not configured to operate in chained mode, it will just nuke every other plugin in the list and make sure it's the only one there. It'll actually delete all the others actively, like repeatedly. Every time the file is updated, it'll remove everything but Cilium. And of course, that means that Istio plugin wouldn't get invoked anymore for new pods, and you can have this thing where they're fighting over the config. So actually, that's why if you look at the documentation for Cilium, they actually have a CNI exclusive faults, which they need for AWS as well, right? Cloud providers ship their own CNIs, and you have to turn that off so that it will not constantly evict other configs. The ordering wouldn't be the problem because we're always at the end. The only thing that could happen is the plugin config is mutated such that it's written out without us in it. And that's the only thing we have to worry about, really.
Are there CNIs that actually, why would any CNI want to be exclusive to begin with? Like it should always expect to be okay with the change.
Yeah. So the Cilium config, it's in their documentation. They say it's for security purposes. Because remember, like fundamentally, the CNI model is a random JSON file executing privileged binaries, in number of them on every node. And if you're an operator, you probably want to make sure that it's not like someone's not maliciously injecting a privileged binary into that chain, right? So I think Cilium's solution is, well, we'll just make sure we're the only one, and you don't have to worry about that, which is like a way to solve that problem, but not ideal in a chaining model. And the actual CNI spec itself does not make that easy to deal with, that scenario. So that's, again, there are some PRs out. I think CNI 1.2 is currently slated to add, or at least I PR'd it, and it's slated for 1.2 to add plugin subdirectories. So basically you can have plugins in a subdirectory as opposed to the main config file. So we won't have these clashes over, I'm reading it in, updating, you're reading it and updating. We're both trying to fight over whose plugin is in the config file. That should solve that problem in CNI 1.2. But that's sort of a flaw with the CNI protocol in my book. Any plans for Istio to run on secondary interfaces? So we don't really care about the interface. Again, like we are executed whenever a specific network is in play, right? So whatever your CNI defined network is, right, KindNet or whatever, like if you have multiple networks defined on your node, we want to be in the primary one or the one you're going to use. And if our plugin is not in that network chain, then we're not going to fire. But we don't care about interfaces per se. We are fired for every pod that is bound for that network, right?
Yeah, I think the question was about secondary networks, and I guess with secondary interfaces / secondary networks, and basically what you're saying is that there is no plan for Istio to work on secondary networks. It is always only on the primary network.
Yeah, multiple networks per node are still a little tricky. Like it will still work. And
only on the primary network.
I believe right now with Istio, I need to check, but I think you actually it'll only handle one network at a time. So like if you have multiple networks and you wanted to say Istio belongs specifically to network B, but not network A, when you install the Istio CNI, you can pass that as an argument, say I want it to be specific. I wanted the plugin to be appended to this network config, not that one. You could do that. But supporting parallel network configs at the same time, both Istio, we don't support at this time. We could, but nobody's really asked for that. Okay, I think that's all the questions.
Sorry, one more thing that I didn't add there. Since the Istio node or the Istio plugin, CNI plugin decides whether or not a pod is ambient,
yes,
on annotations attached to the pod, which are derived from the annotations or labels attached to the namespace, a malicious pod could overwrite its own labels and alter that, right? I mean, do we have security constraints too?
The thing is, though, that for the plugin specifically, this is triggered before any processes start inside the pod. So this happens after the Kubernetes API has gotten the manifest, but before anything has actually been started on the node.
Right, but a running pod which is ambient could switch itself outside of AMP.
Yes, that's correct. Yeah, I mean that's true with sidecars too. Like it could enable and disable its own injection somehow. You'd have to restart it in order to take effect. But yes, that's true. If you had that's generally true of anything in Kubernetes. If you have a pod that is privileged to talk to the Kubernetes API server, it can move itself to a different namespace. It could do all kinds of stuff. Yeah, I mean that is generally true. Yes.
Yeah, no, I wasn't referring to privileged pods. I mean, the ability to modify a pod spec does not require privileges.
It requires Kubernetes API privileges.
Okay.
Okay, so that's the main thing. Okay, so node agent, plugins. Let's see what else. That is pretty much it. Let me also show, if I can, so where most of the magic happens, as far as, like I said, you've got the plugin in ambient, you've got the plugin pushing message events up for new pods. You've got the watcher on the Kubernetes API letting you know if there are new pods to be enrolled or unenrolled, right? Where we actually do that event handling and we do that sort of deduplication is this really sort of big gross function called reconcile pod. And this, it's less gross than it used to be, but basically this is where we're doing the, is it already handled by CNI? Is it not? Do we need to annotate it? Was it enrolled or is it being unenrolled, right? Was the old event had a label, the new one doesn't, so we need to actually unhook ourselves. That's pretty much what's happening there, is in this thing. But again, like in ambient, we are rewriting pod networking rules in one spot, and that is from this node agent. The plugin doesn't do any rewrites. Nothing else, no init containers are doing it. The agent itself is where is the central place where the redirection happens and the rewrite happens. And you can actually, let me see if I can actually show some debugging here. So just to kind of get you some context on like how to read some of the CNI logs. Maybe I've got debug logging enabled, and let me go ahead and actually deploy. Where's my sleep? Come on, man. Samples. All right. I've already labeled this namespace. So I got, it's in HP bin, and so these pods are now captured in ambient, or will be once they're finished starting. So if we go, and these are on worker 2. So if I go ahead and look at the Istio CNI on worker 2, and again, I got debug enabled, and oh, wait a minute, did I install this with okay, no, ambient is enabled. Okay, yeah. So you can see, this is a CNI config, which we're creating, and the CNI event address here is this is basically the UDS path from the plugin to push ambient node events to that node agent. And the other thing too that's worth knowing about the CNI plugins, whether it's ambient or sidecar, is since that plugin is just randomly executed in the containerd context, we actually have this UDS log where we're actually anything logged by that CNI plugin is pushed via another socket to the node agent as well. So we can actually collect logs from that plugin running. Normally we can't do that, but you can't do stuff like standard out logs from CNI plugins because they actually use standard in and standard out to pass arguments to each other. So it's a little tricky to get logs out. And we work around that by shunting logs from the CNI plugin over a UDS channel to the agent so they can be collated up there. All right, so yeah, and you can see ambient CNI server starting a listen server for CNI plugin events. These are the things I just talked about, right? So when this agent starts up, it's going to do all of those things. And yeah, it's actually going to deploy those binaries and update that config file, which it should have already done. And then yeah, this is we're getting events. If you've got debug enabled, you should get. Oh, this is a lot of events. I don't want that many. And you can say it's skipping some stuff like kindnet that it doesn't need to know about. Yeah, go ahead, Sanjeev.
Two questions on IPv6. Is IPv6 supported on sidecar mode? I know it's not supported yet on ambient mode. That's for question number one. And question number two is, when IPv6 is in dual stack mode, are there separate calls for the v4 connection and the v6 connection, or is it all combined in one? So first one was, is IPv6 supported in sidecar mode at the same parity as IPv4?
Yep. And just for context, again, this is when we, ambient is labeled, it's catching sleep events. And yeah, so we actually get, so here's, for instance, deserialized CNI plugin event, right? So the CNI agent got that ambient push from that plugin. It checks the pod to see if it should do things, and it jumps in and does the create in pod rules. Now the IPv6, yeah, sidecars, Istio CNIs doesn't, we have not done a full dual stack pass for sidecar. For ambient, I know we are creating parallel rules for v4 and v6. We do that once for every pod creation. So there are, both sets are created today, or should be created today if you enable IPv6 or dual stack for every pod. But we need to do more testing on the rest of Istio. Like I'm not sure that dual stack. I think as far as like the actual network redirection, we support v4 and v6 everywhere that I know of for ambient, and I think in most places, but not all, for sidecar. We need to do a pass, I think, on sidecars, because there are some places where that's a little inconsistent from what I recall for sidecars. But for ambient, we are from the get-go creating parallel rules always for both, if you turn that on. Or we should be.
Are we officially supporting, do we have an official position on v6 support with sidecars?
I think dual stack is, I think dual stack with CNI is still a to-do. I don't know if there's an official issue. I think there's an official issue out there for it. We don't support fully dual stack and ambient yet either, but again, like the groundwork is in place for that stuff. If you enabled it, then you will get both sets. Whether that works everywhere, including the control plane, is a different story. But in terms of the redirection, we should be covered on the v6 stuff. And then you had another question after that too. Sorry, I forgot what it was.
No, it was really just two. One is v6 with sidecar mode.
Yeah.
And one was dual stack, whether they are separate flows for v4 and v6.
Yeah. When we do create in-pod rules, if you have enabled dual stack, we will create both sets in both tables, right? IP tables, IP6 tables, and IP tables. And if you don't turn on dual stack, we will just create IP tables rules, which you can actually see them echoed here. Okay. That's
the CNI calls, the CNI plugin itself.
It doesn't make a difference. It would simply
v4 and v6 in the same.
Yeah. It will get executed once for every pod, regardless of whether it was dual stack or not. Remember, it's not by interface; it's by pod. So the CNI context, in that case, our plugin might get in the input context from the containerd runtime. It might get multiple interface or previous plugins rather. It might get more than one interface in the input data, and it might get more than one IP in the input data, right? If you've got multiple IPs established for the pod, we would get both of those IPs and we would use them if we got more than one. But it would just be one invocation with multiple data points as opposed to multiple invocations. Yep, Jackie.
Hey, yeah, could you walk through like those rules that were just there, like the T proxy rules? I'm just curious what's happening in those rules for ambient.
Yeah.
That'd be really helpful for me.
Let me try, because I may not remember all of those, but where do we actually do that? Yeah, so I believe that all of that, all that should be defined. Again, Istio, CNI. If you look in package IP tables, this is where this is, create NPOD rules. And actually, that's the one you saw in the log, right? Would be executed. That's where this happens, and all the rules are defined here. Istio has its own IP tables package, which at least now is a little bit intelligent about whether you're using NFT or not, or legacy or not, or v6 or not, and what binaries to use and all that junk. So basically what we do is, the first thing we do always is create separate chains. So let me see how I can actually talk about this in a way that is not confusing. Okay, yeah, I'll just go back here. All right, so the first thing we're doing is creating chains, right? So the way IP tables works, if you're not familiar, and for anybody who watches the recording is not, is you've got these various tables. You've got NAT, filter, mangle. You've got various points in the networking, in the flow, where you can jump in and add your own rules, right? Actually, that's what it's called, is jump, right? But they're these main tables that all Linux systems have. They're predefined, well-known, NAT, mangle, whatever else, filter. They're all there for input and output. It's one big list of rules. And so what Istio is doing here, for instance, is it's creating this thing called a chain, or a side chain, if you will, which is just like a group of rules that is named and sits outside of the main rule set, but you can jump into that side chain from the main rule set and then jump back out. And the nice way, the reason you would want to do that is it's a little cleaner, right? So if you look at the NAT table, for instance, you might see stuff from the kubelet, you might see stuff from the primary CNI. It's a big list of rules, right? But if you have this side chain, you could just say, I just want my rules in this side chain. And rather than put 20 rules in the main table, I can put the 20 rules in the side chain and jump into the side chain with one command from the main table and then jump back out, right? So it's just cleaner. And the nice thing too is that you can just, if you want to delete your rules, you don't have to like filter through everything in the main table. You could just drop your specific named chain, and the jump becomes a no-op at that point, because there's no chain to jump to anymore. So you can sort of, it's just more tidy to deal with it that way. So that's what we're doing here, is we're actually creating these various Istio _ prefixed chains, and we can put rules in those chains, but until we actually do a jump, like for instance here, we're actually jumping into from the primary output, the default NAT output chain, the one that is pre-existing for the whole system, we're jumping into our Istio output chain, right? And that's, again, it's just a redirection, right? It's just like a pointer to another set of rules, and then it jumps back out, right? Pops back out. It's just a sequential execution. So for all of our rules, we create these prefix named side chains just to keep things tidy, and then we append our customized rules into those. So we do a few things here where if I remember correctly, I'd have to go look, but and actually I'll go back to the code, because the code, actually, I've tried to comment why we do this, right? So for instance, we insert jumps to our custom chains, right, which is what I kind of just talked about. And from here on out, we're only inserting rules into our custom chain. So we're doing things here like if we have things like packet marks, right? We've identified, for instance, that this is a packet that is already been captured and is redirected to ztunnel, or is coming back out of ztunnel within the pod, right? We want to know that that packet has already been handled, right? So either ztunnel or us, depending on the context, who has the knowledge, will mark that packet, right? And that's a mark, is like just a bit field, basically, the Linux kernel maintains, saying, yeah, this packet has had mark XYZ applied, so you can identify it uniquely. So this, for instance, is just setting an actual con mark if we get a marked packet. And to get into the Linux weeds, there's packet marks and there's connection marks, and a mark for the connection sort of applies to the whole connection. But you may have packets that don't have a con mark, and vice versa. So this is just something to say, if we get a packet that has a mark that we know about from ztunnel, then go ahead and say this connection is a ztunnel connection. Let's mark the whole connection. We do a few special things here. So one tricky bit here is health check probes. And this was tricky in sidecars too, which is why in sidecars we had to do the whole thing where we actually use the webhook to rewrite health check paths. The reason health checks are tricky is because Istio is about making sure that everybody talking to your pod has an identity and is secured, right? Well, a health check probe is some random unsecured process on the node that is not in the mesh, just poking through to your app, right? It literally has to, like, it's unidentified ingress traffic from some source. So we have to basically have some sort of logic that says, I'll let that through if I know that that's just from the local node and it's just from somebody I know about, right? Because obviously it would be a big security hole to let any traffic in. We have to be able to kind of prove that, yes, this is host node traffic. This is the kubelet calling us. The kubelet is not in our mesh. The host node has no Istio identity. So it is effectively unsecured access, but we have to allow at least the kubelet to have unsecured access, or else health checks would just not work, and nobody wants that. It's always kind of a pain point. Your options are let it through or try to establish some sort of node identity and like alias that, which I think is also what Cilium does to some degree. Either way, you have to special case health checks always for these things. And that's what we're doing here is we are setting up special handling for stuff coming in from the host node. I'll get into that more later, but basically this rule is just saying if it's coming from the host, if it's a host probe, let it through, accept. And then we have this, for instance, this is saying anything going back out from the pod health check port back to the host node, let that through too. This is prevent intercept traffic from app by pod IP. Here, this is basically saying anything coming into the pod that hasn't been marked by us. It hasn't been handled yet, so T-proxy it to ztunnel, right? This is saying if this is something that's already been contract marked, which again is what we did up here. We did this somewhere, yeah. I think, yeah, if this has already been contract marked, they just let it through. We already got it. A lot of this is just standard IP table stuff. If it's been marked, let it through because we've already handled it. If it hasn't been marked, send it where it needs to go. Like that's pretty much what all of this is. And then there's the host probe stuff. And this is anything that is not bound for localhost and does not have the mark. T-proxy this. This is various cases whether it's coming in from the pod IP or localhost or whatever else. If it's DNS. Here we are restoring the con mark because one of the things about marks is when packets enter and leave network namespaces, marks are cleared. The kernel does not track them across network namespaces. So you kind of have to you kind of have to account for that. And actually, when ztunnel itself, if you look at the ztunnel code, anything it proxies, it marks packets with its mark. So we know that a packet came from ztunnel because there's a ztunnel specific mark that we can look for. And basically, all these rules are doing is saying, look, if this packet has a mark that says it came from ztunnel, mark the whole connection as coming from ztunnel. That's pretty much it. So we can treat it correctly. We have some optional rules if DNS redirection is enabled, where we also capture DNS traffic. This has to do with the DNS proxy that ztunnel does, which is sort of analogous to the old DNS proxy that the sidecars did for resolving service entries. Again, a lot of that's kind of the same. Mark it or don't mark it. We don't have con mark in that case because it's UDP, obviously. Let's see. Yeah, if this is outbound and has our mark, let it go. This, these should all be relatively documented. Yeah, if this is outbound, local. Yeah, I tried to actually cover most of these, explaining what they do. But yeah, most of this is just if it's marked and it's already been handled by ztunnel, let it out or let it in, depending. And if it has not been marked at all, then we need to actually grab it and shunt it through ztunnel. And then there's the host probe stuff. All right, so these are all the rules that we create in pod. like I said, host probes are a little tricky. So we actually do create, and this is the one place where we're doing stuff in the host network namespace, unfortunately, but we kind of have to, just for those host probes. Let me see if I can actually find that. Yeah. So, right, host probes, like I said, it's an unsecured, unauthenticated packet from an unknown source coming into your pod. You got to let it in for health checks to work, but you don't want to let anything else in because that's a security hole. And so the way we accomplish this is by doing the one thing we actually do on the host outside of all the pods is we do a SNAT, or a source network address translation. So if we see that this rule, basically there's one rule we put in the host, just one rule, one IP tables rule, and basically that's just saying, look, if a packet is coming into a pod, or it's coming to something we care about, it's coming to an IP set for a pod we have, and we are maintaining an IP set of all the pods on the node. If this is a packet coming to a pod as defined by that IP set, and the socket exists locally on the node, right? It's not a packet coming from another machine that looks like it's coming from the local node, but it's actually the source socket is open on this machine. Then we are going to change the SNAT IP host. We're going to change the host IP. We're going to change the actual IP, right, of that packet as it enters the pod. And then the pod rules will say, okay, anything coming in that has that SNATed IP, where's that rule? Yeah, anything coming in that has that special host side IP, then we assume that's a host probe and we let it through. The reason we do this and not a mark is, again, marks don't live over those network namespace boundaries. When you're coming from the host network namespace into the pod network namespace, any mark we applied outside would be lost. And we could not tell from inside the pod where the heck this packet came from. So the way we do that is by actually using a specific fixed IP, saying anything coming in with this fixed IP, we assume is a host probe. And then outside, we have something that says only do that SNAT if we can prove that the socket that originated this packet exists on this local machine.
Why do we need to SNAT the probe at all? Why can't we let it go through with the host IP?
Because the tricky bit is because host IP is hard to derive. And if you look at the old code from before previous Ambient and also sidecars, and also other CNIs, it's really hard to authoritatively, for all CNIs, figure out what the host IP will be inside the pod, right? There can be multiple devices. There can be network address translation. It's really, really hard, maybe impossible, or at least we've never found a great way to authoritatively be able to know from inside the pod, this is the host IP. Unless you do like weird reverse lookups, which may or may not work depending on what interface you're using. It's really tricky to be correct. So this is easy because we aren't doing it from the perspective of inside the pod. We're snatting it in the host network namespace where we know exactly this is coming from a local socket.
And we snap it to a special IP? Sorry,
yes.
What do we...
We snat it to a special IP, which is defined by an environment variable. Right, yeah, which is right here in the CNI README, host probe SNAT IP. That can be changed. So far, this is more reliable than all the other approaches we used to use. It isn't perfect, and it does require creation of that one host networking rule, but it is minimally invasive because basically nothing else is going to care about this. And so far it's been a pretty clean approach. Better approaches are welcome, but again, like anything that is trying to like guess the host IP from the perspective of the pod is like, you could do that for one kind of CNI, but to do that in a way that works across all possible CNIs is really tricky, maybe impossible, or we haven't found a good way to do it. So, anything that you can do that doesn't require any host side rules at all, that's reliable across all CNIs would be great there. But this was the best solution we could find, and it's pretty reliable. It works pretty well too, because IP tables can guarantee, for instance, that the packet originated from a local machine, and that's good enough for us to say treat this separately, right? Because that means it's actually running locally within the host network namespace.
And to clarify, this is to handle health checks for like workloads, not for the actual Z tunnels themselves. Like obviously there'd be health checks for the Z tunnels.
Yes. Yeah. This is just for stuff, and this is this is also avoids the old approach of having to actually rewrite the host probes, which is what we used to do in sidecar times because we had the same kind of problem of like how do you do that, especially if it's something where and you can't rely on port, right? Because you could have the probe and actual traffic on the same port, and then you can't
Sure.
it's tricky. Um, so this is the one like thing where we do have to create something in the host. It is just one rule. It is grossly unlikely to collide with anything important at all. But if we could improve that and get rid of all of the rules, that would be great. But this works pretty well so far, and it's better than what we've used to use. So yep. Okay. I think and then again, when a pod, we are using IP tables restore generally. So we are basically applying all the rules. We are applying all the rules in one go, and then when a pod is unenrolled, we delete all the rules in reverse, basically, so they're not there anymore. And yep, that's pretty much it. Okay, I think that's it. Is there anything else anyone wanted to see or talk about or ask about? That was a lot.
Awesome. Thank you. Thanks for walking through the rules. It's just helpful to have someone talk through them.
Yeah, I agree. It's tricky. I tried to document it as best they could. They're not perfect, but it's one of those things where every time I do it, I have to like remind myself of like, okay, so we're doing this here and that here and blah blah blah. It's a little tricky.
That was
Okay.
great. Thank you.
Yeah, I think there's still some subtle details on the proxy and the redirect and all this. It is confusing.
Yeah.
Hey, when you do the IP table save and so on, does it only do it in the namespace you're doing it in, or does it do it globally across all namespaces?
We are doing it. We're only operating within the pod network namespace, so we're doing this per pod. So it only aside from that host probe rule, which we inject one time when the CNI agent starts. After that, all mutations of IP tables happen within the pod context per pod.
Right. Yeah, I was just wondering whether the kernel is smart enough that when you do an IP table save inside a namespace, it only
Yes,
does.
it is. It
It
is.
does.
Yes, it's purely localized. It's only you only see the rules for that namespace. There may be rules defined elsewhere that the same kernel is managing, but it segregates them by namespace, so you will not see those. Yes.
Yeah, and it won't even reprogram the other ones just
Correct.
because.
Yep.
Okay.
Can't even. They're not even there. Yeah, it's completely different. Yep. All right. I think that's it. Unless someone else has any other questions. All right.
Yeah. Thank you,
Thank you guys.
Benjamin, and thanks everyone for joining. I think yeah, there's still more we could be talking, but I think we covered quite a good set of topics. And thanks, really. I think this will be a handy reference for people in the future on Istio CNI. Thanks, everyone. We'll put the recording once it's available. Talk to you later. Bye.